A very good morning to all of you. Myself, Professor Dhaval Chandarana, and we are continue on our unit number 6, Mathematically Preliminary Requirement for the Lossy Coding. Guys, as the basic introduction about a unit number 6, we discussed there are the two different things which we go through this particular unit, and it is nothing but a scalar quantizations and a vector quantizations. So as up to the previous lecture, we discussed all the different concept about a scalar quantizations, and from the today onwards, we discuss a second portions of a quantizations which is really important to implement any lossy coding technique is nothing but a vector quantizations. And behalf of a scalar quantizations, previously we discussed a different concept about a Lloyd-Max quantizations, as well as Lloyd-Max quantizations, a different concept about how to generate output, and when you implement a Lloyd-Max quantizations, so what was the basic need to remember to generate a less number of distortions and a less number of mean square quantization error in form of output. So those concepts we will discuss in our previous lecture, and as per the discussions, today we discuss a second and the important concept about a lossy coding technique is nothing but a vector quantizations. So guys, until now we discuss all the concept behind how to perform a scalar quantization. Now onwards we discuss a second concept about a vector quantization, and in form of vector quantizations, today we discuss a advantage of vector quantizations over the scalar quantizations. So guys, as we know that first we discuss the introductions about a vector quantizations, and the later on we compare and find out the different advantage over the vector quantizations with compare with the scalar quantizations. So we start with the vector quantization introductions. First thing, a quantization is one of the efficient tool for the lossy compressions, because now onwards we know that what is the importance or the requirement of quantizations in a lossy compressions, because we are discuss a lots of concept till today's lecture. It can reduce the bit required to represent the source, and we know that what is the definitions of quantizations. They generate a number of range, and to represent on a particular range we define some unique code word. So it can be reduce the bit required to represent a source informations. In a lossy compressions applications, we represent each source output using one of a small number of code words. As previously we know that quantization is one of the process to define some unique code word with a specific source. Like if we says that a range of 1 to 10 is nothing but to a step size, and for to represent this particular step size, or we can say length of 1 to 10 units, we represent a 5 number, so it is nothing but the code which the process known as a quantizations. So I will just rewrite this line. In the lossy compressions applications, we represent each source output using one of the small number of code words. It is known as a quantization. The number of distinct source output value is generally much larger than the number of code words available to represent them, because we know that in a range of 1 to 10 there are the infinite numbers. If we want to consider in the only 10 numbers range, then the representations of code word we generate only the ones. So if we consider that if we not generate any code words for the particular range, then how many numbers we want to store it, and for that we require larger number of time. So that's why the quantization process is the most important concept in a lossy compressions, and behalf of that we discuss a vector quantization. The process of representing the number of distinct output values to a much smaller set, it is a quantizations. So guys, it must be required to remember whenever we discuss about any kind of quantizations in form of scalar or in form of vector, you must be remember it is the process to define a distinct output values to a much smaller sets of called quantizations. So nothing but to define some unique interval for the larger number of sets. It is nothing but the quantizations. So it is the process which is implemented in both the way if we consider as a scalar or if we consider as a vector. Each of the things which should be covered in the quantization process, this figure is really helpful. And what was the figure justified? If you provide some input signal, then the source encoder generates some step size. They can analyze this step size, and based to analyze your step size, they provide as a quantizer input. And now the process of quantizer, whatever the step size, it should be divided or defined by the users. You just justify this particular range and assign some unique intervals to the particular step size, which is should be defined in a source encoder. So after source encoder, you can define some unique intervals for the particular step size. It is the process of quantizer. And after the defining some unique interval for the specific step size, you define the entropy encoder. And in the entropy encoder, they consider or collect each of the unique interval according to your entropy encoder, and then they define a compressed signal. So આપણે એવું કહી શકીએ કે જ્યારે આપણે કોઈ ઇનપુટ સિગ્નલ જનરેટ કરીએ છીએ અથવા તો નંબર્સ ઓફ ઇનપુટ કલેક્ટ કરીએ છીએ, સૌથી પહેલી પ્રોસેસ હશે સોર્સ એન્કોડરની. ત્યાં તમારા બધા જ ઇનપુટનું એનાલિસિસ થશે. એનાલિસિસના બેઝ ઉપર એ સ્ટેપ સાઇઝ ડિસાઇડ કરશે અથવા તો રેન્જ ડિસાઇડ કરશે. એ જે રેન્જ ડિસાઇડ કરે છે એને યુનિક ઇન્ટરવલ્સનું કામ આપવાનું કામ અથવા તો અસાઇન કરવાનું કામ ક્વોન્ટાઇઝરનું છે એઝ પર ડેફિનેશન સેઝ. એન્ડ આફ્ટર unique interval, it should be defined for the particular step size. જે પણ તમે unique intervals define કરો છો એના બેઝ ઉપર they generate the entropy encoder. So it is nothing but જેટલી numbers of unique intervals આવશે એના બેઝ ઉપર એ possibility check કરશે અને possibilitiesના બેઝ ઉપર they perform the encoder process. અને encoder processનું કામ જ એ છે કે તમારે કઈ quantization process, it should be a adaptive, it should be a uniform or it should be a non-uniform. આ ત્રણેય મેથડમાંથી તમે કઈ મેથડ ઇમ્પ્લિમેન્ટ કરશો તો તમને બેસ્ટ આઉટપુટ મળશે એ જનરેટ કરવાનું કામ છે એન્ટ્રોપી એન્કોડરનું. અને એ ડિસાઇડ થઈ જશે then your compressed signal should be sent from sender to receiver end. So it is the process in both the techniques should be implemented if we consider as a scalar or if you consider as a vector. So the sets of input and output of quantizer can be a scalar or a vector. So as definition says, anything about a decisions to take generate some unique interval for the specific step size, the process is known as a quantizer or a quantization. It should be a scalar or it should be a vector. So second thing, we will discuss a type of quantization. We know that there are the two different broad category about the quantization is nothing but a scalar and a vector. First we discuss a scalar. The most common type of quantizations is a scalar quantizations. Until we discuss each and every mechanism about a scalar quantization on different lecture, so we just briefly define what is a scalar quantization in this lecture. So scalar quantizations typically denote as an y is equal to q of x, is the process of using a quantization function q of x. So when we discuss about the scalar quantization, the quantization function q, it is the most important things. If you consider as any of the value x which should be defined in a scalar quantization, then you must be define the particular q of x functions with respect to your unique value to map input value x to a scalar output y. So જ્યારે આપણે scalar quantizations ની વાત કરીએ છીએ ત્યારે q of functions, it is the important part according to your input value. અને તમે જ્યારે scalar quantization use કરો છો તો આ એનું identification છે if you consider as a q of a particular input of x and it should be generated by y. So it is your input value with respect to q, and if you consider as a q, then it's become a scalar quantizations. Next thing or next part of quantization is nothing but the vector quantization. A vector quantizations map k dimensional vector in each vector space r raised to k into a finite sets of vector y to yi to n. Each vector yi is called a vector or a code word and a sets of all the code word is called a code book. So according to the definitions of vector quantization, if we consider or compare with the scalar, the Q function is the most important thing when we decide a scalar quantization. But if we discuss about a vector quantizations, vector quantization is completely depends on a code vector or a code word, which should be defined by the vector I. So as a part of vector quantizations, now onward we are focusing a code book or a code word instead of your particular Q, or we can say a functions of a scalar quantization. So જ્યારે આપણે ડિસ્કસ કરીએ છીએ વેક્ટર ક્વોન્ટાઇઝેશન્સની, હવે પછી જે કાંઈ પણ મિકેનિઝમ, ટેકનિક્સ અથવા તો અલ્ગોરિધમ આપણે સ્ટડી કરશું ડિપેન્ડ્સ ઓન અ વેક્ટર ક્વોન્ટાઇઝેશન્સ, ત્યારે આપણું મેઇન ફોકસ હશે એના કોડવર્ડ્સ અથવા તો કોડ બુકની ડિઝાઇન ઉપર. અત્યાર સુધી આપણે એનું ફોકસ કર્યું હતું એની ઇનપુટ્સ વેલ્યુ ઉપર, એના સ્ટેપ સાઇઝ ઉપર, એની મીન વેલ્યુ ઉપર, બીકોઝ till we discuss about a scalar quantizations. Now we discuss, or now onwards we discuss a vector quantizations. અને જ્યારે આપણે વેક્ટર ક્વોન્ટાઇઝેશન ડિસ્કસ કરીએ છીએ ત્યારે એનું મેઇન ઇમ્પોર્ટન્સ હશે એની કોડ બુક અથવા તો કોડવર્ડ ડિઝાઇન. So that's why we discuss or differentiate between a scalar and vector quantization. Now we see what is a vector quantization. VQ is nothing but the vector quantization is a lossy data compression method based on a principle of block coding techniques that quantize a block of data instead of a signal samples. As previously earlier discussed, now onward whenever we implement a vector quantization, our main focus is to represent or to build a codebook design instead of a signal sample. VQ exploits the correlation existing between a neighboring signal samples by the quantizing them together. So the concept behind a VQ is nothing but to generate a specific code with respect to your neighboring sample signals. So same way in a scalar quantization we decide a boundary or a decision boundary. On the same way we will consider as an input signal, or we can say neighboring input signal, and based on a neighboring signal we generate a quantizer, and in form of quantizer we will decide the code book. VQ is one of the widely used and efficient technique for the image compressions. So guys, now onward we can compare with the scalar. A scalar quantization is mostly used in form of voice or in form of video type of source data. But if we consider as an vector quantization is widely used when your source input is form of image, or we can say image compressions. Since last few decades in the field of multimedia data compressions, VQ has received a great attentions because it has the simple coding structures and can provide a high compression ratio. So they can achieve both the goals, a simple mechanisms for the implementations as well as high compression ratio, which is the basic requirement of a data compressions. So in the last decade VQ getting a more number of attentions due to those two concepts. It should be implemented is very simple, as well as the compression ratio should be very high. In a VQ based image compression technique has the major steps, namely what are the different steps if you want to implement a vector quantization. Let's see. First thing, you need to design a code book, and it is the most important part when we implement a vector quantizations. Second thing, VQ encoding process, and the third, VQ decoding process. So the three steps, it's a very easy to implement and very easy to understand any of the vector quantization process which we implement with the different algorithm. That's why it should be really getting a great attentions on a last decade. In VQ based image compression, first image is decompressed into the non-overlapping subblocks, and each subblock is converted into the one-dimensional vector termed as a training vector. So the first steps of VQ based image compression is nothing but to design a codebook in form of part of a codebook design first you decide or first you design a block of data which should be converted into the one-dimensional information, and it's known as a training vector. So guys, it is the definitions of training vector, and you must be remember whenever we discuss a vector quantization, training vector word is the most important thing, because in any kind of or any dimensions type of image, first you need to convert into the one-dimensional data, and it is known as a training vector, because now onwards or nowadays the image should be a one-dimensional, two-dimensional, three-dimensional, or maybe a 4D image. So each kind of simples data, first we need to convert a one-dimensional block, and it is known as a training vector. Next, from the training vector, or we can say one-dimensional data, a set of representative vectors are selected to represent the entire sets of training vectors. So all the training vector we should be not consider as a VQ encoding process. Some of the sample according to the neighboring values, we select some of the blocks from the training vector, and it should be represented in an encoding process. So that's why the memory space is much lesser required to store all the training vector compared with the some samples data. આપણે બધા જ ટ્રેનિંગ વેક્ટરના બ્લોક્સને કોડ બુક ડિઝાઇનમાં સ્ટોર કરવાની જરૂર નથી. એમાંથી મોસ્ટ પ્રોબેબલી અને જે એકચ્યુઅલી રિયલમાં યુઝ થઈ શકે એવી મોસ્ટ પ્રોબેબલી કોડ વર્ડ્સને આપણે કોડ બુક ડિઝાઇનમાં સ્ટોર કરશું. The sets of representative training vector is called as code book, and the each representative training vector is called code word or a code vector. So first we need to convert our image into the one dimensional. It is known as a training vector, and each training vector is known as a code word or a code vector, and the collections of code word or a code vector is nothing but known as a code book. So as per this line, we consider or we select some amount of training vector from the all data. It is known as a code book. So how to design a code book? It is to represent, first we need to convert our image into the one dimensional block. It is known as a training vector. After selecting a specific training vector, it is known as a code book. તો આ જ પર્ટિક્યુલર સ્લાઇડની અંદર આપણે એનું ફર્સ્ટ સ્ટેપ્સ જે VQ એટલે કે વેક્ટર ક્વોન્ટાઇઝેશન ટેકનિક્સના મેજર સ્ટેપ્સ છે એમાંથી જે પહેલું સ્ટેપ છે હાઉ ટુ ડિઝાઇન અ કોડ બુક એ અહીંયા આપણે કમ્પ્લીટ કરીએ છીએ. અને કઈ રીતે ડિસાઇડ થશે? સૌથી પહેલાં તમારી જે પણ ડાયમેન્શનલ ઇમેજ છે એને આપણે વન ડાયમેન્શનલમાં કન્વર્ટ કરશું, એને આપણે કહીશું ટ્રેનિંગ વેક્ટર. બધા જ ટ્રેનિંગ વેક્ટર ડિસાઇડ થઈ જાય પછી આપણે એને સમ ઓફ ધ સેમ્પલ્સ ડેટા કલેક્ટ કરી લેશું અકોર્ડિંગ ટુ ધ રિક્વાયરમેન્ટ, એટલે સમ સ્પેસિફિક ટ્રેનિંગ વેક્ટર સિલેક્ટ કરવાનું કામ કરશું, અને જે સ્પેસિફિક ટ્રેનિંગ વેક્ટર સિલેક્ટ કરીએ છીએ એને કહીશું કોડ બુક, અને પર્ટિક્યુલર ટ્રેનિંગ વેક્ટર જે આપણે સિલેક્ટ કર્યા છે એને આપણે કહીશું કોડ વર્ડ અથવા તો કોડ વેક્ટર. The goal of VQ or vector quantization code book generation is to find then the optimal code book, the ideal, the lowest possible distortions when compared with all other code book of the same size. So guys, it is the most important, and you must be remember the line, you need to design those kind of code book which should be possible lowest distortions rate compared with the same size of code book. Like એક એક્ઝામ્પલ આપી દઉં કે તમે કોઈ એક ઇમેજ આપો છો a.jpg, એમાંથી તમે કોડ બુક ડિઝાઇન કરી અને એમાં તમે 5 ડિફરન્ટ સેમ્પલ્સ લીધા અને એને કોડ બુક ડિઝાઇન કરી. હવે જ્યારે તમે b.jpgનું કોડ બુક ડિઝાઇન કરો છો તો એવરી ટાઈમ તમારે એવી જ કોડ બુક ડિઝાઇન કરવાની છે, અથવા તો એવી જ કોડ બુક ડિઝાઇન થવી જોઈએ કે પ્રીવિયસલી જે કોડ બુક ડિઝાઇન થઈ છે એનાથી ઓપ્ટિમલ લોએસ્ટ પોસિબલ ડિસ્ટોર્શન્સ ફાઇન્ડ કરી શકો with reference of same size of code book. And how we design a code book we will already discuss in our previous slides. The performance of VQ based image compressions techniques depends upon the constructed code book, because it is the major part of VQ quantizations, or we can say vector quantization. The search complexity increase with the number of vector in a code book and minimize the search complexity. The tree search vector quantization scheme was introduced because we know that there are the lots of code words or a training vector available in particular code size or a code book. For to find out or some specific code vector on a training vector, the search complexity is much larger or increase of complexity due to find out some unique code word, and for that reason we use tree search vector quantization process for to reduce or minimize search complexity. એક્ઝામ્પલ આપી દઉં કે તમારા કોડ બુકની અંદર 100 કોડ વર્ડ છે, એટલે કે 100 વેક્ટર કોડ ટ્રેનિંગ વેક્ટર છે. હવે એવરી ટાઈમ તમે 100 કોડ અથવા તો ટ્રેનિંગ વેક્ટર સર્ચ કરવા જાઓ અકોર્ડિંગ ટુ યોર ઇનપુટ, તો they take a much larger time to find out some unique code words. So we can reduce the time as well as search complexity. We can use a tree search vector quantization techniques in a vector quantization for reducing a search complexity. The number of code vector n depends on two parameter, rate r and dimensional l, because we know that the image should be in form of dimensions, 1 dimensional, 2 dimensional, 3 dimensional, or maybe a 4 dimensions. So the code book design or a code vector, it's nothing but the training vector n. It depends on a two parameters. First one, how much compression rate you can achieve from the process is known as a r, and what are the different dimensions of your source data is known as a l. The number of code vector is calculated using the following formula. Is nothing but a number of code vector n, it's 2 raised to r into the l, and l is nothing but the dimensions, rate you need to achieve after the vector quantization process, and is the equations suggest this, the equations of multiplications of rate into your dimensional with respect to 2. So the 2 raised to r into l, it is the final value of number of code vector. And what is the number of code vector? It is the actually training sets, or we can say number of code word which we need to store in a code book. And what is a code book? It is the major first step to implement any vector quantization process, where r is the rate in form of bit by pixels and l is nothing but the dimensions. So it is the process of vector quantization in a simple figure. First we define or decide a source output. As according to the source output, we need to define a group of into vectors. It's nothing but the training sets. Find out the much possible smaller training set, and according to the training set we design a code book. And for to reducing a search complexity, we using indexing. તો આપણે શું કરશું? ઇન ફોર્મ ઓફ એન્કોડિંગ સૌથી પહેલા આપણા જેટલા પણ આઉટપુટ હશે એને ગ્રુપમાં ડિસાઇડ કરી દેશું. ઇટ્સ નથિંગ બટ અ ગ્રુપ ઇન્ટુ ધ વેક્ટર્સ. ઇટ્સ નોન એઝ અ ટ્રેનિંગ વેક્ટર્સ. ટ્રેનિંગ વેક્ટરમાંથી બધા જ ડેટા કોડ બુકમાં નહીં સ્ટોર કરીએ. જે સેમ્પલ્સ આપણને મળે છે એમાંથી આપણે ફાઇન્ડ કરીને ક્લોઝેસ્ટ કોડ વેક્ટર ફાઇન્ડ કરશું. એટલે એવું સમજો કે અહીંયા તમને 1000 ટ્રેનિંગ સેટ મળતા હોય તો એમાંથી આપણે મેક્સિમમ 100 ક્લોઝેસ્ટ ટ્રેનિંગ વેક્ટર ફાઇન્ડ કરી લેશું. એને આપણે કોડ બુકમાં અસાઇન કરી દેશું. કોડ બુકનું કામ શું છે? આ તમને જે ક્લોઝેસ્ટ ટ્રેનિંગ વેક્ટર મળ્યા છે એ બધાને સ્ટોર કરી એને કોઈ યુનિક કોડ આપવાનું, અને એ કોડ ઇઝીલી આપણને સર્ચ થઈ જાય, ફાઇન્ડ થઈ જાય, એની માટે આપણે ઇન્ડેક્સિંગ ટેકનિક યુઝ કરશું. સો ઇટ ઇઝ ધ પ્રોસેસ ઓન એન્કોડર હેન્ડ. ઓન અ સેમ વે ઇન્ડેક્સના બેઝ ઉપર આપણે ટેબલ્સ જોશું. ટેબલના બેઝ ઉપર જે ઇન્ડેક્સ આપણને મળે છે એના બેઝ ઉપર આપણે કોડ બુકમાંથી એનો કોડ ફાઇન્ડ આઉટ કરી લેશું, અને કોડ મળે છે એના બેઝ ઉપર વી ડિસાઇડ unblocking, or we can say reconstructions. So it is the process on an encoder side. This is the process, or we can say reverse process on a decoder head. and the complete process of encoder and decoder, it is known as a vector quantizations. So first we take as an output collections of data. Based on of collected data, we generate the training vectors. There are the lots of training vectors. Based on a lots of training vectors, we select some of the training vectors, and those selected training vector we decide in a code book. What was the code book? Is nothing to define your each and every training vector to assign some unique code word. And for the reducing such complexity, we use the indexing. That is, we can say a tree structures vector quantizations. So it is the process of encoder end. We send an index value on the decoder end. If we receive an index value, then we based on an index we search into the code book. We find out a specific code word with respect to index, and finally we reconstruct our actual data. And the combined process of encoder and decoder is nothing but the vector quantizations. So guys, it is the actually introduction about a vector quantization. What is a vector quantizations? What is the basic requirement or you need to remember if we implement a vector quantization, and what is the process to implement a vector quantizations? So it is the block diagram. Now we compare, or we can say the advantage of vector quantizations over the scalar quantization, because we now know both the things, what is a scalar, what is a vector. So the first thing, vector quantizations provide a flexibility in choosing a multi-dimensional quantizer cell shape and is choosing a desired codebook size, because in a scalar quantization we never focus on any kind of dimensions, we never focus according to the codebook size, we just focus on the mean value and decision boundary. So it is the one of the advantage of vector quantization to the scalar quantization. You have a flexibility of selections of dimensions as well as size of codebook. The advantage of VQ over the SQ is the fractional value of a resolutions that is achieved, and the very important for the low bitrate applications where low resolution is a sufficient, because on a particular section we have a flexibility to selecting a dimensions of information source which is not available over the scalar quantization. So when your data source should be the lower resolutions, the vector quantization is really faster and easy to implement. Third advantage, for the given rate VQ, result is a lower distortions than the SQ, because we have a flexibility to selecting a codebook size, and every time we decide or design much smaller quantizations error or a smaller distortions according to the same size of codebook. That's why a VQ result is a lower distortions than the SQ. And the last advantage, VQ can utilize the memory of the source better than SQ, because due to the SQ there are the no flexibility of codebook size, so we require a much larger space for the designing or for the storing of code words into the codebook with respect to VQ, because VQ have a number of flexibility for the selecting codebook as well as storing a training vector. So guys, today we stop this vector quantizations discussion on particular lecture. I hope you are clear what is a vector quantization, what is a comparison of vector quantization over the scalar quantization, and if you implement a vector quantization, so what are the three major steps you must be implemented to represent a vector quantization, with the starting of designing codebook, then encoding process and a decoding process, and how the process should be gone through the vector quantization we will discuss our previous slide with the help of block diagram. So I hope you are clear, I hope you are enjoyed, and I hope you are learning how to perform a vector quantization in image compressions. Thank you so much.